Hey guys, teaching at home at the finest, right? Makalahim Mountain right behind me, my farm, my house. You're on my porch right now. That's where this video is taken. Um, so last strategy for 8.1. This section is pretty deep. And so I hope that you actually watch all 5 videos and then after that go practice the problems that are in the back of the chapter or the section. Okay, so book problem is a must for this section. My math lab is being assigned, but that's just a small sample of it, so I would encourage you to go ahead and do book problems for this section. Okay, so last part of the video series for 8.1. Here we go. So for this example, we will have the integral of 1 over 1 plus e to the x dx. All right, so along the line with the sneaky u situation, you can see here that if you think about letting u be e to the x, well, that's not going to work out because the derivative of e to the x is e to the x, which is not up here, right? It's not attached to the x up here, so that's not going to work. And then if you let u be e to the x plus 1, okay, that's still the same issue. So what are we going to do this time? Okay, so in this situation, we are going to do one of the things that I love the most in mathematics, which is, besides multiplying by 1, is adding 0. Okay, so this strategy is the adding 0 strategy. What do I mean by that? Well, you know, when you go add something in, if you have something added into the fraction, you're going to go ahead and subtract it right out. So that's adding 0. And what do I want in this case? In this problem, I have 1 plus e to the x. In the numerator, I have 1, right? What I'm going to do is I'm going to add e to the x on here. Well, I can't just go ahead and add e to the x. That's not going to work because I would change the problem, right? But if I go and say, well, I'm going to go ahead and subtract out e to the x. Okay, so what did I just do? I just added 0. Okay, I added in e to the x that wasn't there before, but I'm going to subtract it right out. So that's adding 0. So I didn't really change the problem at all, just the way it looks, right? Why do I want to do that? I want to do that because if you think about this part right here now, as one part of the numerator, and this is the second part of the numerator, I can now actually split into 2 fractions, and that would be nice because then in the first fraction, if I just have 1 plus e to the x divided by 1 plus e to the x, well, that's really just 1 dx. And then minus, it's okay, the integral of the second part, the blue part right here, e to the x over 1 plus e to the x dx. Whoa, what just happened? That was like almost like magic, right? So what did I do? I added 0. And what's my 0? Plus e to the x minus e to the x. That's 0, right? And then I take this part right here, rewrite it as 1 fraction over the same thing, which is 1. And then the second part of the fraction is e to the x over 1 plus e to the x, and that's the minus in between them, right? So if you think about like redoing this, if I get a common denominator and I add these 2 fractions together, this is what I have. Okay, nice. Now we can just go ahead and take the integral because that's pretty easy to do. Now the integral of 1 dx is just x, right? Minus, think about a u substitution here. Let u be, in this case, what do you want to let u be? Well, the whole entire denominator right here, e to the x plus 1. Okay, then du is e to the x dx. Nice. That's what we have up here. That's du. So then that becomes the integral of 1 over u du, and we have seen this over and over and over again. That is ln of absolute value of u. All right, and then go back to my problem. The answer would just be x for the first part, and the integral of this will be ln of 1 plus e to the x. And I don't need the absolute value, as I said before, because I know e to the x is positive plus 1 more is positive. And again, don't forget the plus c. All right, so let's go back and review. Okay, started out with this problem right here, 1 over 1 plus e to the x dx. You run into an issue because if you try to do a u substitution right away, that's not going to work because there's no derivative. The du is not going to show up right there. So a pretty awesome trick of adding 0. Okay, so that's adding 0 right there. What just happened? We added in e to the x, and then you subtract it right out. Then with that, we split that into 2 fractions, and both of them are very manageable. All right. All right. So the last of the basic integration techniques. This is probably one of the harder things to see. Suppose you have the integral of ln of x minus 1 all to the 7th power multiplied by ln of x all divided by x. Okay, at first you're like, oh, no problem. I'm just gonna let u be ln of x, and then I will go ahead and have 1 over x at the derivative, but that doesn't work, right? Because this right here to the 7th, that's going to be weird, you know? So the trick, again, for this video is adding 0. So what we're going to do here, we're going to add 0. What 0 am I going to do? If this, see, this is ln of x minus 1, and it's all to the 7th power. If I had ln of x minus 1 again, then I can make that to the 8th power. So I'm going to try that. ln of x minus 1 to the 7th power. And I am going to say, hey, let's say ln of x minus 1 again. But I can't just go, I'm just going to go ahead and minus 1 right there just so I have what I wanted, right? I have to go and add 1 to it. Okay, so that is the adding 0 trick. Minus 1 and then add 1. That's 0. I didn't change the problem, right? Now, how does that help? It helps because if we think about this right here as ln of x minus 1, think of it as a sum where the plus sign right here is our connective between them. And I'm going to go ahead and distribute this into here. Okay, so I'm going to distribute this guy right here into here, and I'm going to distribute this guy into here. Okay, so what do I have? ln of x minus 1 to the 7th multiplied by ln of x minus 1. That's one more. So really I have ln of x minus 1 to the 8th plus ln of x minus 1 to the 7th, because that multiplied by 1 is itself all divided by x. All divided by x dx. So you see what just happened there. I use a distributive property. 7 of those copies multiplied by 1 more, that's 8 copies. And then 7 copies multiplied by 1, that's just 7 copies still, right? Now I'm going to go ahead and write them separately as 2 fractions. So this becomes ln of x minus 1 to the 8th power over x dx plus the integral of ln of x minus 1 to the 7th power over that common denominator there dx. And as you can see now, we can do a nice simple u substitution. We'll go ahead and let u be ln of x minus 1. That means du is the derivative of ln of x is 1 over x dx. There you go. Nice. Because that's what I have right here. 1 over x dx, that's du, right? So basically this is just the power rule right here. So this becomes in structure of that, right? The whole problem is basically just the integral of u to the 8th power du plus the integral of u to the 7th power du. So the answer will just be 1 over 9 u to the 9th power plus 1 over 8 u to the 8th power plus c. That's a very nice u substitution. And the answer, if we write it in terms of x, it would be ln of x minus 1 all to the 9th power divided by 9 plus ln of x minus 1 to the 8th power all divided by 8 plus c. Okay, so this was a very simple u substitution with the help of adding 0 and distributive property to split those 2 fractions out.